Okay, so we're finishing up with Chapter 2. This is Lesson 3, and we are going to talk about naming acids and covalent compounds. So let's start with acid nomenclature first. Our cation, which is our positive ion, is always going to be H+. All acids start with H. Now for our anion, we have two options. We can have a single element, or we can have a polyatomic. And depending on what we have, that is going to dictate how we name the compound. So for acids, when it's H and a single element, so H plus and single element, these are referred to binary acids. And we simply start by naming hydro, and then we take our negative ion, whatever it is, and change the ending to and I'll give you some examples on the next slide. For acids with H plus and a polyatomic ion, these are called, so H plus and a polyatomic ion, these are referred to as ternary acids. 8 turns into ic, and they're left one off here, and ite, please write this in, turns into us. So we refer to this as atic itis. So it sounds like an illness. So if you have a polyatomic ion that ends in 8, you're going to change the ending to ic. If you have a polyatomic ion that ends in ite, you're going to change it to us. So let's look at some examples here. We have H2SO4. So sulfate is our polyatomic. So we're going to change this to sulfuric. So the 8 changed to ic. So this is sulfuric acid. In H2SO3, SO3 is ite, so this is going to become sulfurous acid. So our ite became us. So atic itis. Notice the difference between ternary acids and binary acids. Here's a binary acid, so we start it with hydro. This is sulfur, so we change it to sulfuric acid. And then HCl, again another binary, we start with hydro, and this becomes from chlorine to chloric acid. So notice how the binaries start with hydro and the ternaries do not start with hydro. Even though the compound starts with H, we simply take the polyatomic, change the ending to ic or us, and they all end in acid. All right, inorganic naming and writing practice. So let's review some of these. Let me get a new slide here. So number 1, nitrous acid. The us tells us that it came from ite, right? Atic itis. So this came from nitrite. So we know H is +1, and nitrite is NO2 -1. So a +1 and a -1, our formula is simply HNO2. Hydroiodic. This tells us it's a binary acid because it starts with H. So we know that we have an H, and iodic came from iodine. So H is +1, I is -1, it's simply HI. Number 3, they want us to come up with the name. So I see that this is a ternary acid because it's 3 or more elements. I have a polyatomic ion. Once I memorize my polyatomic ions, I'll know that this is carbonate. Go back to the disease, adic, itic, itis. So 8 turns to ic. So this is carbonic. Remove the ATE, replace it with IC, carbonic acid. Number 4, this is a regular compound, but it is a ternary compound because it contains a polyatomic. So in a ternary compound, I simply name the metal. So this is potassium, and then I name the polyatomic, which is permanganate. Permanganate. Okay. Number 5 is a binary compound. However, I do notice that I have a transition element here. CO falls in groups 3 through 12. So I'm saying to myself, they combined at a 1-to-1 ratio. So whatever the charge is on the S, which is -2, then the cobalt had to be +2. So I'm going to use a Roman numeral for this one. So this is going to be cobalt, Roman numeral 2, sulfide, because binary compounds end in IDE. 6, I have iron 3 carbonate. So they're telling me that they want me to use the +3 charge on the iron. I know from example 3 that carbonate is CO3. It has a -2 charge. I can tell that because if I look here, I can see that this is a 2, and that 2 came from the carbonate. So when I drop and cross on this, it becomes Fe2. I have to put my CO3 in parentheses because I have to drop that subscript of 3 outside of it. And number 7. So just as we learned that hypochlorite HClO had only one O, hypobromite has the same thing. So we're talking about BRO minus. So there's only one O in a hypo. And Na is plus. So this is just a 1-to-1 ratio, so it's just simply NaBrO, sodium hypobromite. All right, let's talk about some general rules for molecular or covalent nomenclature. This is a review of basically how we name covalent compounds using numerical prefixes. So first general rule, if we had to put it into rules, the element closest to the metals is written first. Second, if both are in the same group, if both elements are in the same group, then the one closest to the bottom is written first. So what this really equates to is the element with the lowest electronegativity is written first. However, not all of you have memorized the periodic table trends. We know that electronegativity increases as we go from left to right across the periodic table, and it decreases as we go from top to bottom. So that's what essentially this is saying. The element closest to the metals is written first. It's going to have the lower electronegativity, and if both elements are in the same group, then the one closest to the bottom is written first because it's got the lower electronegativity. We always change the second element ending to IDE. And fourth, Greek prefixes are used to delineate the number of atoms of each element. And what's really important here is mono is never used if the first element is 1. So for example, if I have CO, this is just simply carbon. We just name it, we don't use the prefix, but we use it on the second one, monoxide. And remember, we can't say, we know the prefix for 1 over, according to this chart is mono, but we can't say monoxide, we can't have two vowels next to each other, so we always drop. Just like if we had tetra, we don't say tetraoxide, we say tetroxide usually. We don't say pentaoxide, we say pentoxide. So anyway, those are just some tidbits. All right, let's continue. So we'll do a little practice here. We have N2O5. So the prefix for 2 is di, and that's nitrogen. And 5 is pent. We're going to drop the A, pentoxide. In the next one, iodine, there's only one. Heptafluoride. Hepta is 7, and fluoride is fluorine, so F7. The subscript comes after it. The hepta is before the fluorine, but we write the subscript after the element. So we have dihydrogen, so we have 2 H's. Selenide. So this is for selenium, and there's only one, so we just write H2Se. And tetraphosphorus. Phosphorus is P. Tetra means 4. Hexoxide. Hex is 6, and oxygen, so O6. We're going to talk a little bit about some other organic nomenclature. For right now, I'm just going to talk about alkanes. Recall that alkanes are a hydrocarbon, which means that they only contain hydrogen and carbon, H and C only. They are all single bonds. And they have a general formula of CnH2n plus 2. So for example, if I have 3 carbons, remember that carbon has to form 4 bonds. So if I put 3, because N equals the number of C's, if I put C3, H, 2 times 3 is 6, plus 2 is 8, and I have 1, 2, 3, 4, 5, 6, 7, 8. So this is C3H8. If I wanted to name it, the prefix for 3 is prop, and it's all single bonds. So that means it's an alkane, and it's going to end in ane. So this is propane. Then there's substituted alkanes. Primarily these are our alcohols. And what that means is that an alcohol has a functional group of OH. So if I wanted to take the same example and add an OH group to the end, this is no longer propane, but propanol. And that tells us that it's an alcohol. This could be written as C3H7OH, or it could be written as C3H8O. The preferable, or what you see mostly in the text, is this. And what is an isomer? Same molecular formula. Different structural formula. Therefore, different chemical and physical properties. And if we have time in the spring, we will go more into depth in the organic realm. Like, we're not even going to talk about cis and trans isomers right now. Not going to talk about any of the other functional groups, but I wanted to go over these because some of the chemicals or things that we're using may be from the alkanes or the alcohols, so I want to make sure everybody can recognize them. All right, so last slide. Draw and name and give the formula for 3 isomers of pentane. So pentane, pen tells us that there's 5 carbons, so C5, H, 2 times 5 is 10, plus 2 is 12. So my formula, see how I just used that formula, CN, H2N, plus 2, to figure out how many H's I need. I don't need to figure it out, I could simply just draw it. And I know that each carbon gets 4 bonds, so all of these are H's, and if I count them all up in the end, I have 12 H's. So this is pentane. This is one of the first isomers. It's normal pentane. Now when I create an isomer, remember that I am going to take an H off and I am going to move it to the middle. So I'm going to take this one off and I'm going to move it, say, here. So my second drawing, I move that C to an interior carbon, and I now have to name this. Remember, when we name an organic compound, we number from left to right or right to left so that the functional group gets the lowest number. So 1, 2, 3, there's a functional group, or 1, 2. So I'm going to number from right to left on this one. I have 1 carbon, 1 is methyl, and it's off the second carbon. So this is 2-methyl. My parent group is now parent chain is only 4 carbons long, so bute, and it's still all single bonds, so 2-methylbutane. Now I'm going to take 2 carbons off. It means I can only put them in the middle, because if I put them on the end, I only bend the chain, I don't make a new compound. Make sure all my bond lines are there for my H's. So now it doesn't matter which way I number it because the middle carbon is still a second. I have a methyl group and a methyl group, so 2 methyls is dimethyl, and it's off the second carbon, so this is 2-dimethyl. My longest chain is 3-prop, and it's all single bonds, so propane. In each of these, my formula is C5H12. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 12. And same here, C5H12. So you can clearly see that the molecular formula is the same, but their structures are very different, which means that they have different physical and chemical properties. So the last question is, what is the alcohol derived from butane? Write the formula, draw the molecule, and name it. So let's just throw butane up here really quick so you can see it. We did it before. So we have C4H10. If I want to make this an alcohol, I need to add an OH group. So I'm going to take off the last H, replace it with OH. So now this becomes butanol because of the OH. It's actually called N-normal butanol. It might be called 1-butanol. So we have the formula. No, we don't have the formula. So this is now C4H9OH, or you could correctly write it as C4H10O. Again, most likely you'll see it like this if it's written somewhere. Not saying that you won't see it like this, but this is probably the more preferred. All right. So that's it for Chapter 2, big review of atoms, molecules, and ions, and nomenclature of inorganic and molecular compounds.